Hear, hear. Hear, hear. Hear, hear. Parkinson's Podcast. Welcome to the Hear, Hear Parkinson's Podcast, where you will hear from special guests covering the world of Parkinson's with a deep dive on the World Parkinson Congress and a look at how the WPC has helped make extraordinary progress in the Parkinson's community by creating space for people with Parkinson's to have a seat at the table.
Here. We're back with another fresh new episode of the podcast. Here, leading us all up to the all-important Congress in Phoenix, Arizona at the end of May this year. Today's special guest is Professor Richard Smeyne from Jefferson University. Welcome on board, Rich.
Good morning, good afternoon to you.
Thank you. Yes, it is. It is afternoon. For those of you listening in, it's not awfully important, but we are doing this cross-Atlantic, cross-border, cross-anything. So yes, it's afternoon here, whereas it's early morning in the US, but that's not the important part. The important part is you will be speaking about Parkinson's disease and exercise, Rich.
Yeah.
What a little sneak preview, please.
Sure, be glad to talk about it. So I have been doing work in Parkinson's for close to between 30 and 40 years, looking at exercise, looking at all kinds of issues in Parkinson's disease. And in as the WPC goes, for the past couple meetings, I've actually been speaking on one other subject that I work on, which is the role of environmental agents in causing Parkinson's disease, particularly viruses. But this year, I'm really excited to be able to talk about our work that we've been doing probably for 25 years now, looking at the effects of exercise and how exercise can modify the progression of Parkinson's disease. So, it's not generally known, but, myself and Mike Zigmund, who this session that I'm speaking in on the Wednesday is dedicated to, we're probably one of the first two people who actually sort of described exercise as modifying the pathology of Parkinson's disease. And this goes way back. And, we both can't take all the credit. And we actually originally, so we wound up collaborating for many, many years. Unfortunately, Mike died a couple years ago in a fast progression of ALS. And that's why we are actually sort of dedicating to this. And for people who are coming and are listening to this, I'm really happy that actually Mike's daughter is going to be able to join us there because she lives in the Phoenix area. And so it's really sort of an honor to be able to honor Mike and his work on this. Cool. But, this was founded, it's really a funny story. I'll tell you a funny story about how this all started and how exercise became a thing. And it will admit that I'm going to admit some things here that I don't talk about often. So I had a postdoctoral fellow in the laboratory named Kieran Faraday. He was an Irish guy who had joined my lab. And he came to me one day and said to me, I have this idea that exercise and environmental enrichment will actually prevent mice from developing, the loss of cells we see in Parkinson's disease. And let me step back just for anyone listening. So all of my studies are preclinical. All of the studies that I do in my lab are working with animal models of Parkinson's disease. It's only actually for the last 5 weeks or 10 weeks, actually, that I've started to do some clinical studies on exercise. But so everything I'm going to be describing at the conference has to do with animal models of Parkinson's disease. And so So going back, Kieran said to me, I think that, exercise is going to help. And I looked at him straight in the eye and I said, that might be the dumbest thing I have ever heard. And he said to me, I said, how would exercise stop like MPTP, which is, the model, which is a dopaminergic toxin. It blocks mitochondrial respiration. It kills cells like common in many cases of what we think is Parkinson's. So anyway, he just like kind of like shrugged his shoulders and walked away, because I'm thinking, okay, well, that was dumb. What else, Anyway, about 4 months later, he walks into my office with about 20 different slide boxes filled with, sectioned brains of rats. I'm sorry, of mice. And he says to me, could you do this analysis here? And so, you can see a microscope here, if you're looking here, but it's audio. I always have a microscope next to my desk. It's what I love to do. So I spent the next like week and a half analyzing the pathology of all these animals, walked back to him and said, thank you for wasting my time. Why are you giving me completely normal animal brains? And he
what?
looked at me and he said, well, I didn't tell you, but all of those animals were exercised and got all the toxins. So literally the exercise 100% rescued all of the pathology that we normally saw. So I am not a particularly proud person. So I said to him, well, I guess we're changing the entire direction of the laboratory as of that moment.
Amazing.
So I put the last 25 years of working on exercise to a very stubborn postdoc who didn't listen to me. Unfortunately, Kieran died very young. He died last year. He was in his young 50s at that point. But I tell the story to people, off the cuff, just showing that, sometimes the smartest guy in the room is not you. And and so anyway, with that, I mean, literally, and I'm not kidding, I walked into the laboratory that day and I said, we're going to stop a whole bunch of projects. We have to start working on this.
Amazing.
And so we published that very quickly. We published that study, and it came right after a strange study that Mike Zygmunt published. And that was another one that was like kind of weird. I always call it the most bizarre study. He took rats. Okay, so I worked with mice. He was working with rats. And there, the Parkinsonian lesion is that you inject them with a compound called 6-hydroxydopamine, and that causes all the substantia nigra neurons to die. What he did in his study was he took an animal and he put a cast on the rat. And he forced the rat then to use the limb that would normally be completely not useful because of the Parkinsonian lesion. And what he found in this casting, because he made the animal use that other paw, was that the lesion was really significantly reduced. So while that wasn't really, quote, the exercise we think about today, that was really the first description that forced use and making someone use it could actually stop that thing. So those two papers came out together. So Mike and I were actually competing against one another at that point to get the message out. And I always, we always talk about wanting to be first in things. In science, you want to be last. So if you were to go to PubMed, which is shows all the papers, and you type in exercise rodent neuroprotection, Mike's last. I'm next to last because it's published one couple months before mine. But they were, so anyway, so Mike and I were competing against each other, and when I say competing, it was a friendly competition. Mike and I, we didn't know each other well then, but we were colleagues, and so ultimately, this opened up the field and the idea of exercise. And so over the last 25 years, and the things that then now I'll be talking about is sort of in the half hour or so I'll be speaking. I'm going to use about the first 10 minutes to sort of tell that story. I think I'm going to make it public and give Kieran the credit for really coming up with this idea, and then talk about historically for like 5 or 10 minutes what we've been doing in the last 25 years. It's really sad that 25 years I'll cover in 10 minutes. Kind of your life, it's kind of, well, there's my life, 25 years, here's 10 minutes, hitting the highlights. And then I'm going to spend the last 20 minutes talking about the studies that are not published yet. And I have a really phenomenally talented team right now. What's nice is it's led by my wife, Michelle, who has been running our exercise program in the laboratory for probably the last 15 years. And then with a very, very talented graduate student who's actually going to be at the meeting and is actually helping on a roundtable named Tabitha Rodriguez. I'm going to be really presenting her thesis work, which is all on this. And that's, so, we know how much exercise an animal has to do. We know now what exercise does genetically, what is the key genes that have to change to get exercise. And what's most exciting, and this is something that I really will highlight there, is, people always say, oh, this is only in a mouse model, or this is a rat model. These aren't people. And, we can cure Parkinson's disease in a mouse 1,000,000 times and it never works in humans. Well, this is one of the few times where exactly what we found in animals that was neuroprotective has translated almost identically to humans. We've shown you have to get a certain amount of exercise for a certain length of time at a certain level to get 100% of protection. And then if you do it less, you get some less protection. Then below a certain threshold, you get no protection. Well, that's exactly what the Sparks trial has shown, to the exact numbers that we found. You have to get like the heart rate and a certain amount of aerobic exercise. I mean, it's identical. This is one of the most beautiful translations from an animal study to human studies. And I think that's really important because that suggests that the genes that we're going to find in animals, which are much easier to find in animal studies than in human studies, we hope that they translate, and that translation, and I'll be talking about all the genes now, hopefully will translate to small molecules. And, I joke, I need to be the one to patent it, because if I can find exercise in a pill, it's going to make ELPs look like nothing. But because, if you told people you don't have to go to a gym, you don't have to work out, just take this and they'll do the same thing, that would be great.
You will change the world. You'll change the world. Everybody wants the pill.
So right now we give ourselves an injection and we lose weight. We can take a pill and exercise. I mean, this is the world. We're going to turn into what the old show, The Jetsons, where we just sit around all day and
wild. Well, I think one thing that I'm thinking about, Rich, is there's always the question, we need to take a break for a commercial. All right.
Yeah, that is so. We are so popular, so that companies are queuing up all the way outside to do a little commercial and tell a bit about themselves. So here is a message from our sponsors. Please stay tuned. We will be back with more fun about exercises and PD just after this.
This episode is brought to you by two of our friends who are sponsoring the World Parkinson Congress, our friends at Blue Rock Therapeutics and our friends at Rune Labs. I'm excited to tell you a little bit about both of these great partners. Blue Rock Therapeutics is a clinical stage cell therapy company focused on developing cellular medicines for people living with neurological and ophthalmic diseases. Blue Rock's investigational cell therapy for the treatment of Parkinson's is currently being tested in a phase 3 clinical trial called Expedite-2. You can learn more about that trial and other things that Blue Rock is doing on their website at www.bluerocktx.com. Now, our other sponsor for this podcast, our friends at Rune Labs. Let me tell you a little bit about what they're doing. Strive PD is a free app powered by Rune Labs that uses FDA-cleared Apple Watch and iPhone movement data. Strive PD helps people with Parkinson's understand their symptoms, optimize their therapy, and stay connected to their care team. For premium access, Strive PD Guardian provides proactive coaching and personalized AI reports that offer support between visits, helping individuals improve quality of life and receive the right treatment at the right time. Download Strive PD for free on the Apple App Store, or you can visit their website to learn more and also download it straight from their website at www.strivepd.com today. I'm excited to say you will be able to visit with both of these companies at the upcoming 7th World Parkinson Congress in the exhibit hall, as they will both be exhibiting. Now, back to our podcast.
Hello, welcome back to the current episode of Here, Here, the podcast leading us all up to meeting each other and 4,500 others in Phoenix, Arizona at the end of May. And also welcome back to Professor Richard Smeyne, who will tell us a lot still about exercise and PD.
I'm going to jump in, Edgar, because I had a question right before the commercial. And so, Rich, first of all, this is super exciting. I mean, I'm really looking forward to your talk at the Congress, and I think it's just going to be a very packed plenary session on that Wednesday morning. Just the fact that you've got such great results from the research that you're now looking at from, like you said, from mice models into human models. A lot of people talk about when you diagnose someone early, there's always this interest in how early can you diagnose someone, and then what are the ethics around it? Like if you diagnose someone even before they officially have a diagnosis, right? I mean, if you early diagnosis, people will talk about the ethics around that. Like, well, how do you diagnose someone early if you have, say, a blood test or a biological exam? And if you have no actual treatment for them, is that even ethical? There's a lot of questions around that. I mean, with the exercise and what you're showing is that this is incredibly has a real potential impact on, are you thinking that it delays the onset of those potential symptoms, or is this is just very exciting because it is something people can do. What are your thoughts on that?
Yeah, so I think this is one where actually I think there would be hardly any ethical issues here, in terms of it. I mean, we do know that, Parkinson's disease in many cases has a very long prodromal period, where you have expression of what we call the non-motor symptoms, whether it be constipation, sleep disorders, it's cardiac, hypotension kind of issues. And these can be many, many years. And this is not everyone, but a lot of people. We don't have great biomarkers, so this is still a huge need for Parkinson's disease, the ability to sort of find PD before we get to the more, well, I won't say more debilitating, but debilitating motor issues, and I'm one of the few PhD researchers who's actually the director of a clinical Parkinson center probably in the world. Most Parkinson's are run by MDs. So here at Jefferson, in our comprehensive centers, PhD actually, and myself am actually the director, which actually is great because it lets me see a lot of patients, and talk to patients and interact with patients, which is, by the way, is why I love the WPC. The WPC is one of the only meetings where you have the synergy of researchers, clinicians, and most importantly, the people with Parkinson's, and importantly, their families, who can show up. And first off, I personally, it is the most energizing meeting as a researcher. I mean, we sit in our labs, we go to meetings with clinicians and scientists, and we talk about our things. But when you're in that kind of silo, sometimes you miss the impact of what you're doing, and get to, get to see what the impact is. More importantly, we get to hear what's important to the people who have the disease in their families, rather than what we think is important. And I have to admit, the people with the disease, what they think is more important is more important.
Yep.
And so this has directed a lot of researchers, when you talk to people and you say, well, that's all great, but I don't care about that. I care about this because this is my reality. And this is what my reality is going to be if it's an early person. And that's why our exercise is why we've continued to work it for many, many years, because it is something that doesn't cost really anything to do other than motivation. It costs motivation because you have to do it. You can't just gently, exercise if you're going to affect the progression of Parkinson's disease. Okay. You actually have to do a significant amount, what we call aerobic exercise.
Tell
Okay.
us a little more about this, because this was
Yeah.
one of Edgar's questions, is when you talk about exercise, tell us just what do you mean?
Yeah. So, this is what we've shown in animals and what has translated to what is now the parameters and what's the SPARKS-3 trial, which is right now one of the biggest ones on exercise, is that you have to generate hypoxia. So to get what we think is going to be sort of neuroprotection here, okay, is you have to reach 85% max heart rate of your own individual maximum heart rate. So that's going to change with your physical condition as well as your age. So it's sort of an individualized factor. You have to do it 4 times a week for about 20 or 30 minutes. Okay. 4 times a week. So that
means I have to break a sweat.
You have to break a sweat. Right. There are other forms of exercise that people have published and have shown that are helpful, like Tai Chi. And maybe I would say there's a lot of interest right now in boxing. That's a huge thing. Boxing makes you sweat. I mean, these people sweat. So one of the issues that, and we talked about this with some of our physical therapists, and because we run several Rocksteady boxing programs right in our clinic here in Philadelphia, is that we really haven't measured the exertion in that. And it's hard to, because where you put on pulse oximeters on hands, but they're inside of boxing gloves, and they know how you're banging it against them. You can put chest things around them. So that it would be really great to sort of understand what we're seeing in the boxing, because that's a lot of people like boxing, as for PD more than just getting on a treadmill. What we're talking about, though, are really treadmill exercise, but treadmill you can put in your house, kind of thing. And so that's like rather than more boxing. So we're doing mostly treadmill work, the equivalent of treadmill work. We put mice on running wheels, voluntary running wheels. And so anyway, so you've got to do this heart. If you go down to 66% of your maximum heart rate for the same amount, you get some partial protection. And we have to be key here is we're talking about protection of what's left. Okay. So exercise doesn't make new neurons grow or anything like that. So one of the things that Eli has sort of talked about early detection would be greatest. So most of the time we always say when someone walks into a clinic and they have a slight tremor in one hand or one finger, on one side, by that time, about 60 to 70% of the neurons in the brain in a place we call the substantia nigra pars compacta, which is all the dopamine neurons, they're dead. So all you have left is about 30 to 40% of the neurons there that to try to keep function for the next 15 to 20 years of your life. So, so this is, some of the early studies and everything that we've seen in animals suggests that if you do that rather rigorous exercise, you can actually stop the decline. The neurons that are left get protected. Okay. One thing that I will be previewing at this and its early studies is we actually asked the question is, and so we've shown that, I should say, we've shown that not, exercise, and the SPARKS trial has shown that the UPDRS Part 3, which is the motor component of the Parkinson's testing that everyone does, doesn't seem to progress if you've done that for 6 months. It seems like it stays stable. If you do that lesser amount of exercise, the numbers go up. So you get a little bit of progression, but not as much if you don't exercise at all. Okay. So there's graded amounts, and any protection is great because it's slowing the disease. If you do it early, though, if we were to have a biomarker for, let's say, when you start constipation 10 years before that motor symptom, maybe you have 60% of those neurons left or 70. Now, if you protect them, you maybe we'll get to the point where you never progress beyond gut PD or sleep PD, disorder PD. You never really get that pathology in the brain. That would be great. And I know a lot of people with Parkinson's, if you told them that your Parkinson's disease is only going to get as bad as you not literally sleeping well and having constipation, but you're never going to see the motor symptoms, people would be thrilled. Again, it's not a cure. None of this is a cure for the disease,
Right.
but it is a treatment. And I know in the clinic now. Yeah,
Hold on a little bit, please.
sure.
What is the difference between a cure and treatment?
Yeah.
Yeah. So, I mean, a cure to me would be that you would replace the cells that are lost and therefore not have to be on any medications. Basically, you would cure. Now, we're talking about the motor parts of the disease, not the
Yeah.
non-motor, because that's a whole different thing. But so there are studies going on now. There's clinical trials now where they're using induced pluripotent stem cells. They're trying to replace the cells that are lost in the dopamine. If that would become a very successful therapy, I would put that in the cure category.
Right.
Because there you're actually replacing the neurons that are lost. Whereas what I'm doing is trying to protect what you have left.
It's a
So,
complicated question, actually, Edgar, because everyone will define cure differently for sure.
right.
I've had a lot of patients and a lot of people with Parkinson's say, if you could just stop my progression, but
They would
not
be killed.
that to me that would be a cure to just stop it and halt it. Although to someone else like to you, Rich, that's not a cure, right? You want to be able to, to reverse it. A vaccination would be a cure to be able to prevent it from happening in the first place. But
Right. Exactly. And, so we think about that. So, my whole laboratory works in neuroprotection. Okay. I would love to put myself out of business. I mean, I think
yes,
that's the goal of every scientist and every clinician that goes to these meetings is to put ourselves out of business. And, I've got 3 or 4 or 5 years more in my career, here. I would love it. Boy, wouldn't it be nice to go out with, at
amazing.
least some types of Parkinson's disease being cured. Okay. I mean,
Yeah.
that's the other thing we have to realize now is not all Parkinson's disease is the same.
No. That is something we definitely know. If this is so good, are you coming to Phoenix riding a bike?
Okay.
I
You
think
know
the
there are
question is, are
there is
you
a huge
exercising,
crowd.
Rich? Are you following your own advice?
I'm the control group.
Exactly.
No study is valid without a significant control group. And sacrificing myself to be the control group. We joke among people, and this is actually, we laugh about it now. This is actually an issue. One of the symptoms of Parkinson's disease is depression and apathy. It's not, it's actually it's not because you have PD that you get depressed. PD causes depression and
Yeah.
apathy. Well, to exercise, you need to be motivated. So we have to overcome not only the just, oh God, exercise, but we also have to overcome the apathy
Yeah.
that is part of the disease to get people to be motivated to do it. And that's why we joke about exercising the pill would be so much easier. The thing we always joke about is we should have a group where we put a treadmill in their house and we put clothes on top of it, like everyone does. Is it enough to look at a treadmill, at least partially? I mean, we joke about it because because it's a real thing. It's a real thing to get people to do this level of exercise. Now, any exercise is going to be good. People, do Tai Chi. That's great for balance, gait, and everything. It doesn't seem to be that neuroprotective, that when we think about trying to spare the neurons. But there's all kinds of aspects where any amount of exercise is good for some aspect of the symptoms you see in PD.
I laughed when Edgar brought up the exercise because I think around 15 or even 20 years ago, I remember hearing Stanley Fahn give a talk about how important exercise was, just like this. But this was like 20 years ago. And Stanley Fahn, for those who don't know, founded the World Parkinson Coalition, a very well-known movement disorder doctor. And of course, someone asked him about his own exercise regimen, and he pretty much said the same thing, Rich. Well, I don't necessarily do that, but you should be doing it. And I just thought it was very funny because you know how important it is, but it again, it goes back to the motivation and you have to make it their number one priority every day. And that's just hard in life. Life is complicated. People have jobs and kids and families and you really have to make a serious commitment on top of, like you said, dealing with depression and apathy and other things. So
Yeah,
it's
I mean, fun, that's why I think boxing has been so successful in other things, is because
yes,
it's communal. Okay, so you're with a group of other people, as
yeah,
well as it being a little more fun, and you get to hit things. I mean, and to get
yeah,
kind of thing. Whereas,
yeah.
it seems, treadmill exercise is more of a solitary kind of
Boring.
thing. It's kind of, yeah, let's just admit it.
Yeah, I
But
think the
but it
boxing
works,
and dance, like the dance groups also do quite well because again, there's that social aspect of it and it's fun. It doesn't feel like you're working out,
right?
but you are. But
And
yeah,
with that, it is very possible that both boxing and dancing will be doing the exact same thing. But I don't think we've taken the time, and we should, as clinically, to actually let's measure the parameters. So if we know you need to get to 85% max rate for 4 days a week, well, why does it have to be a treadmill? Okay. If anything would do that, but I don't think people have gone to dance class wearing monitors and, pulse oximeters to actually know the kind of exercise they're getting out of here. And I think that would be wonderful and easy to do in some ways, and is to sort of quantitate how much exercise you're getting from these things. Like we said, if you are out of shape a little bit, you don't have to do as much exercise to get to that 85% max rate that if you're like a long distance runner where you may never get there, kind of thing. So, this is where it's individual. It would be great. And I think it would be a wonderful thing and very easy to do, inexpensive way. But, if we can quantitate all this, maybe one can correlate and say, well, you don't want to do treadmill, but you can dance and do the same thing, or you can box and do the same thing. We need to do that. That's an open question in the field.
Right,
amazing.
right.
I just want to
Yeah.
say for our listeners, just so you're clear on this, Dr. Smeyne, Rich Smeyne, who's our guest today, will be having a more in-depth conversation about this very topic, the neurobiology of exercise and Parkinson's, at the morning plenary at the World Parkinson Congress on Wednesday, the last morning, saving the best for last. Well, don't tell anybody else I said that. Saving the best for last, Wednesday morning, May 27th. But he's going to be joined by a couple of other incredible leaders in this space. They'll be talking about, with Dan Corcos, who's talking about, is exercise neuroprotective and the evidence from the clinical trials. And then Erica Franzen from Sweden is going to talk about exercise-related structural and functional brain changes and associated functional outcomes. And then we're going to have our friend Jimmy Choi, who is someone who's very motivated, who has Parkinson's, talking about how his own health journey, how he kind of went from not being super fit and healthy to being super fit. Like, how did he motivate himself? So this is going to be a very, very good conversation. So if you're enjoying this podcast, make sure you're there Wednesday morning for this session. It's going to be incredible.
So I should say a funny story with that. So are we at what, 8 a.m. I think it starts?
You're at 9 a.m. You start at 9 a.m.
So it's a little nicer. So several years ago when I gave a talk at the WPC, it was an 8 a.m. meeting, and it starts to fill up around 8:30, 9 o'clock. So as I was speaking, it was filling up. But the only people that I said were there at 8 in the morning were the people with Parkinson's, because they're not sleeping anyway. So so it's 9 o'clock's a little bit better for all of the other people who are going to roll out of bed,
Well, yeah, there will be a lot of people not sleeping. And then, of course, our friends from Europe, once they're in Phoenix, they're going to be 9 hours off of their normal time zone. So they're going to wake up anyway at 5 a.m. So they'll be there in the morning for your talk. Very excited at 9 a.m., I think, to hear you present.
Good. We're running towards the end of this, Rich. There are only 2 questions left that we ask all the guests on the podcast. I don't know if you've heard any of the previous episodes.
No, I haven't.
So you would know the upcoming question.
Nope, they're going to be a surprise.
Okay. Number 1 is, You're on a deserted island. Only you and a palm tree, and oh, there's a record player over there. If you could choose just one record to play, what would it be?
It's solar powered, so it works. What's your record?
okay.
What's your song or what's your album?
You're free to choose between
Love Over Gold, Dire Straits.
Nice.
what?
I am a giant Mark Knopfler fan.
Yeah. Excellent.
Nice.
Excellent. It could be a good intro to the next and final question, which is, you're in an elevator, stuck between two floors. Who do you want to be stuck with? Anyone?
No
dead
time or
or
space
alive?
continuum. Yeah, dead, alive,
Time or
any
space
year.
okay. Ramón y Cajal, Santiago Ramón y Cajal, the father of neuroanatomy. And if anybody has ever wants a fascinating book, if you're in neuroscience, it's called Recollections of My Life. It was an autobiography that he wrote. He's my scientific hero.
Wait, say his name again, because I just wrote the book down. I'm gonna get it.
He was a Spanish a Spanish physician who got polio and was forced to be inside, and because of that, he was an artist and he described the structure of the brain. His name's Santiago Ramon, Ramon, with a Y, Cajal, Cajal. He has had his pictures done at the Metropolitan Museum of Art. I mean, there's coffee book tables, the most amazing things. And when you see sort of drawings of the brain, you see these ink diagrams, they're almost always his. So
I've seen his artwork, but I didn't realize that's who you were talking about.
yeah,
Absolutely
so
incredible.
My PhD is in neuroanatomy, is where I officially trained in neuroanatomy and neuropathology. So he's my hero. So he would absolutely be one, even though I don't speak Spanish. And then currently, this will be politically incorrect, but Tony Fauci, who was our previous director here of the National Institute of Allergy and of Infectious Disease. About the other part of my lab that we haven't talked about right now in Parkinson's disease that I study is the role of the immune system in Parkinson's disease, specifically how viruses may cause Parkinson's disease. And we've worked on flu, we've worked on Western equine, we've worked on COVID in our lab, and we still do work with all of those viruses right now. Despite everything, I think, Tony had two careers, one describing AIDS and sort of like helping the AIDS patients, and then his second career forced onto him by the COVID pandemic. I mean, he did it despite all the political headwinds. His book about his life is also another, great read. So I guess those two would tie together my whole career. So those would be the two I'd have in my elevator. So Tony's still alive, so there's still hope that one day I can actually. I've never met him. I've gone to listen to him talk, but never met him. So if he ever listens to this, give me a call.
We'll see what we can do. We'll see what we can do for you. Those are both great candidates, and I know we didn't have enough time to talk about all your great work on viruses, but you're just so fascinating to have a chance to talk to, Rich. And I know you're a huge champion of the WPC. So personally, I just say thank you for all your support of the work that we do. And it's been really great for me to have this opportunity to be a part of the podcast with you today.
Oh, this is fun. And tell a scientist you want to talk to them about their work. We'll never shut up.
Very good. Excellent, actually. Thanks a lot for being with us today, Rich. And we look forward to that Wednesday morning in Phoenix to hear even more.
Yeah, I look forward to seeing everybody there.
Meet up. Beg pardon?
I'm looking so forward to seeing everybody out in Phoenix.
Good,
Amazing.
good.
Thank you.
Thank you, and goodbye.
Thank you.
Thank you for listening to the Hear Hear Parkinson's podcast. We hope today's conversation inspired you. If you'd like to experience the energy, connection, and impact of the global Parkinson's community firsthand, join us at the 7th World Parkinson Congress, May 24th to the 27th, 2026 in Phoenix, Arizona. Learn more at wpc2026.org. This podcast series is made possible with support from Blue Rock Therapeutics and Rune Labs.